Hi, today's video is on climate change, fitting the pieces together. The topic of climate change is like a puzzle with many different pieces: oceans, the atmosphere, ecosystems, polar ice, natural and human influences. Scientists have been working on this puzzle for more than a century, and while there are still gaps in our knowledge, most experts feel that we have a complete enough puzzle to show that human activities are having an adverse effect on our planet. Today we're going to look at many of those puzzle pieces, the evidence behind them, and the conclusions that we can draw from them.
Hey, it sure is warm for January. Dear Tim and Moby, what does global warming mean? From Walter. Well, global warming means that the Earth is heating up. In the last 100 years, the surface temperature of our planet has risen about 3/4 of a degree Celsius, or a little more than 1 degree Fahrenheit. Most scientists believe it's going to get even warmer in the years to come. What's making temperatures rise? Well, there are probably many factors involved, but most scientists agree that the biggest contributor to global warming is the increase in greenhouse gases like carbon dioxide in our atmosphere. These gases trap in heat and cause a natural heating up called the greenhouse effect. Inside my mom's greenhouse, the sun's radiation comes in through the glass and heats up the air inside. But that air doesn't go anywhere, so it becomes warm and humid, which is good news for the plants. On Earth, a similar thing happens. The sun's radiation travels through our atmosphere, heating up the Earth's surface. Excess greenhouse gases in our atmosphere trap that heat in. So the Earth eventually becomes hotter, just like the inside of my mom's greenhouse. So what's the big deal if it gets a little warmer? Yeah, well, warm winters can be nice, but increased temperatures can cause problems for the environment. Coral reefs die due to warmer water temperatures, and fish have to go elsewhere for food. Earth's polar ice caps hold a lot of water. A difference of a few degrees in temperature can melt this ice, causing the sea levels to rise, which could flood coastlines, affecting the habitats of plants and animals and people. Who knows what will happen to all the animals and people who have to adapt to new temperatures and wetter environments? Well, there are things that we can do to stop the accumulation of greenhouse gases in the air. Burning fossil fuels generates carbon dioxide, so the more you walk or bike instead of driving, the cleaner the air will be. And the less electricity you use, the better. Trees and green plants take in carbon dioxide and produce oxygen. So, planting trees and clearing fewer forests is a good way to start. Boy, this weather sure is freaky. I didn't mean you should plant trees in the yard. Well, I guess his heart's in the right place.
So here are the topics that we're going to look at today. What is it that changes climate? Is climate change real? How do we know that it's real? Why should we care? How sure are scientists about this? And what is next and what can we do? Scientists have a good understanding of what has changed Earth's climate in the past. One thing that they look at is incoming solar radiation. That's the main climate driver. The sun's energy output did increase about 0.1% from 1750 to 1950, and we saw temperatures increase by about 0.2 degrees Fahrenheit in the first part of the 20th century. But since 1979, as we've been taking measurements from space, the data doesn't show us any long-term change in total solar energy. But the Earth has been warming, so we have seen an increase in temperature, but not an increase in solar energy output. We also look to repetitive cycles in the Earth's orbit that occur over tens of thousands of years, and this can influence the angle and timing of sunlight. So we see it's something called precession, and we see the Earth's north pole shift and change its tilt over time. In the distant past, drifting continents have made a big difference in climate over millions of years, and because this changes the polar ice caps and in turn alters ocean currents, and this transports heat and cold throughout ocean depths. So those drifting continents can also contribute to climate change. Also, huge volcanic eruptions can cool the Earth by injecting ash and tiny particles into the stratosphere, and also changes in the concentration of greenhouse gases. And this occurs naturally and as a result of human activities. And a change in the greenhouse gases can also influence Earth's climate. Here we see a picture of the greenhouse effect. Earth's surface absorbs heat from the sun and then re-radiates it back into the atmosphere and into space. Much of this heat is absorbed by greenhouse gases, which then send the heat back to the surface to other greenhouse gas molecules or out to space. Though only 1% of atmospheric gases are considered greenhouse gases, they are extremely powerful heat trappers. By burning fossil fuels faster and faster, humans are effectively piling on more blankets, heating the planet so much and so quickly that it's hard for Mother Nature and human societies to adapt. Here are some of the common greenhouse gases. There are many substances that act as greenhouse gases, but the two most important are the ones that are here in the red boxes: carbon dioxide and water. Carbon dioxide comes from a variety of sources. For example, plants take up carbon dioxide in the air to make wood, stems, and leaves, and then they release it back into the air when the leaves fall or the plants die. The concern today is that fossil fuel use is putting huge amounts of carbon dioxide in the atmosphere at a rate faster than the climate system can adapt to. In addition, the warming resulting from carbon dioxide and other greenhouse gases also has the effect of increasing evaporation. This adds water vapor to the atmosphere as well. Water vapor is the most important gas in the natural greenhouse effect, contributing about 60% of the effect to carbon dioxide's only 26%. So water vapor is a stronger greenhouse gas than carbon dioxide. And in fact, satellites have detected an increase in atmospheric moisture over the oceans at a rate of about 4% per degree Fahrenheit of warming since 1988. So this additional water vapor amplifies the warming effect. One question that a lot of people have is, could the warming be something that's just natural, something that is just bound to happen? Well, certainly past temperatures have been higher and lower than they are today. Certainly the Earth goes through cycles. And also carbon dioxide concentrations have also varied throughout time. But today, the carbon dioxide released by human activities is far above the amounts in the previous 800,000 years. Most climate scientists think that this carbon dioxide is triggering the increase in the temperatures that we've seen. The Earth is getting warmer by virtually every measure that we know, and the temperature has been well above normal for more than 25 years. Although increases of 1 to 1.5 degrees Fahrenheit over the last century or so may not sound very threatening, remember that that's a global average. The warming is stronger over land than over oceans and in the higher latitudes than in the tropics. Snow and ice reflect the sun's energy back to space. Without this white cover, more water can evaporate into the atmosphere, where it then acts as a greenhouse gas, and the ground absorbs more heat. Snow and ice are melting at rates unseen for thousands of years. In Glacier National Park, for example, there were 150 glaciers in 1850, and today there are 26. Sea ice is dwindling too, especially in the northern hemisphere. Satellites have seen average Arctic sea ice shrink by 2.7% per decade from 1978 to 2006, with faster melting in the summer. In this graph here, you can see the difference between 1979 to 2000, and then the green line is 2007 and the purple line is 2008. So you can see the differences there. A warmer atmosphere can hold more water vapor, and this also leads to heavier rains and more snowfall. Intense precipitation over the U.S. has increased 20% over the last century. But as storm tracks shift, it can also mean that some areas get drier. A 2004 study by the National Center for Atmospheric Research found that the percentage of the Earth's land experiencing serious drought had more than doubled since the 1970s. Increased warmth has also affected living things. For example, the Japanese keep very detailed records on the blossoming of their Tokyo cherry trees, so they know that they are blooming 5 days earlier on average than they were 50 years ago. Also, mosquitoes, birds, and insects are moving north in the northern hemisphere. Another question a lot of people have is, how do we know all of this info? How do we have all of this information about past climate before people were even around? Well, scientists can learn about the past climate conditions from things such as tree ring analysis, fossil evidence, and analysis of patterns and chemical composition in coral skeletons and in ice cores. We also know about the present changes taken from observations at the surface and in the atmosphere. The main tool for both past and present climate analysis are computer climate models. Much like the models used to forecast weather, climate models simulate the climate system with a three-dimensional grid that extends through the land, the ocean, and the atmosphere. The models perform trillions of calculations that describe changes in many climate factors in this grid. The models project possible climates based on different scenarios that cover a range of assumptions about global population, greenhouse gas emissions, technologies, and fuel sources. The model results provide a range of possible impacts based on these assumptions. So here you can see one of these models that shows several different possibilities based on different scenarios. If our emissions over the next 100 years are high, if they're kind of in the middle, or if they're low, or if there's no additional carbon dioxide. So we get to see the possibilities based on several different scenarios. A common critique of climate prediction is, if weather model forecasts aren't reliable more than a week out, how can models predict climate decades into the future? While weather and climate models are based on similar physics, they are not predicting the same thing. Weather forecasts look at the day-to-day changes on a very local level, and subtle chaotic atmospheric variations, or things that could happen, possibilities in the atmosphere, they make short-term weather forecasts very difficult more than a week out. Climate predictions are focused on longer-term influences of things like the sun, oceans, land, ice in the atmosphere. Well, instead of predicting a temperature at a particular place at a particular hour, climate modules project an average temperature over a year or longer in a very large region over the entire globe. Climate models are not only used to look at how climate might change, they're also used to figure out why it's changing. When models are run with only natural influences from the sun and volcanic eruptions, they say that during the latter half of the 20th century, we would have expected little change from the normal conditions. So it's the blue line that you see on the graph here. Only the addition of human emissions, like greenhouse gases and ozone, produce the model results in red that most closely reproduce the black line of actual observations. So the black lines are the actual observed temperature, and the blue line would be, if we took people out of the equation, what the temperature should have been. So although they aren't perfect, climate models can reproduce many of the larger features of climate change in Earth's distant past, and they replicate the pattern of warming in the last 100+ years. This gives us confidence that they correctly identify that the warming is due to man's activities, and that projections of future warming are realistic. And that ends part 1 of the climate change video. Please make sure that you have in your notes information on greenhouse gases, climate change effects, and how do we know that the climate is changing.